first lecture of class 10 ICSE physics. This course are completed by the very short duration video which is full of the deep knowledge, and the course, you can say the name of the course is the pure physics with Rishi sir. Okay, so the name is not important, the important is the content of the course. So let's start with the first chapter of ICSE class 10, that is the force. What is force? Before we start with the force, we have to know that what are the state of the body. A state of the body can be of two types. One is at rest, or the body will be at motion. That means to convert the motion, that is the state, we are using a physical quantity that is called the force. That means the force is a such physical quantity that can change the state of the body. Another thing the force can do, that is that it can change the shape, change the shape or size of the body. Means by applying the force, two things can be happen. One is change in state, and the second thing is the change in dimension. Okay, the change in state means that is a body is in rest, we apply some force on it, then the body starts moving with a velocity v, and after some time it reaches over here. So that means the body come from A to B, which is possible due to the applied force. Here the arrow denotes it is a vector quantity. Okay, so if we go actually the bookish definition of the force, so that will be a force is that physical cause which change or tends to change either the dimension of the body or the state of the body, that is the inertia. The state of the body, the state of the body means that the body will be in rest or will be in motion, that is called the inertia. It is very important concept, and that will come in the first laws of motion of Newton's first laws of motion. Okay, so now one important thing is the force is a vector quantity. Why the force is a vector quantity? Why? The big question is why the force is a vector quantity, and what do you mean by this vector quantity? There are two types of quantities. One is the vector quantities, and another is the scalar quantity. So the vector quantity means which have the magnitude and plus the direction, and the scalar quantity is which have only magnitude. I think you know all these things. The things which you don't know, that is the vector quantity is the nothing but the cross product. This is the cross product, and the scalar quantity is always the dot product. Okay, that is the force. Force is equal to ma. You can say that force is equal to m cross a, and as force, this is what m cross a. What is that ma? Ma is nothing but the magnitude of the force. If the direction of the force you have to know, then you have to apply another thing, that is the n cap. N cap means it is a unit vector which shows the direction. N cap, that is the any vector. If it is a vector, if a vector a is a vector quantity, then it has magnitude. Magnitude is given inside the bar, and the second is the its unit vector, that is the direction. So this direction is nothing but the direction denotes the direction A denoted by vector A by magnitude of A. That means if only MA is there, that means this is nothing but the magnitude of the force, that is the this portion is nothing but MA. Now direction depending upon the force, we can say that whatever the direction of the acceleration, that is the direction of the force. That means if you apply some force and due to that force that the body moves towards the direction of the force, then the acceleration is also towards the applied force. That means if a body is there, if a body is there and if you apply some force on it, that is the F, and due to that if the body having the mass m and if it has a velocity v is also a vector quantity, u is the velocity v, then you can say that after some time the body is at rest, that is the u is equal to 0, and after some time the body goes on, and at some instant if you find that the velocity of the body is v after time t, after time t the velocity of the body is v, then the body is accelerated. And what is the acceleration, direction of the acceleration? The direction of the acceleration also in the direction towards the applied force. So this the direction is the nothing but the direction associated with that force, means m into a will give you the magnitude of the force, and to determine the direction you have to know the what is the direction of the acceleration of the body. So why, so this is the introductory class. In the next class we will discuss about the types of force, but the big question is the why the force is a vector quantity. This is very important question, and this is very important concept, and you don't get this concept in every book. So that means force has the magnitude and have the direction. Okay, that's why it is a vector quantity. When you give the direction, then you should give an arrow over the f, and if f you write just f, then you can uh, write the f like this. Okay, that is the only magnitude part is there. Okay, so that means the force depend upon the direction. That's why it is a scalar quantity and vector quantity both have the magnitude. The extra thing which has in the vector is the direction. That means the direction is the very important part of the force. Now why it is very important part? Now you consider one mass m, and so what are the forces acting over the mass? The force which is acting over the here it is the m into g, that is the weight of the body, m into g. And from Newton's third laws of motion, you know that this is the normal reaction force N, which is acted opposite to the weight. And as N is equal to mg, so the body is at rest. That is the net force acting on the body is 0. Sorry, F net. This become F net is equal to 0. So V is equal to 0. That is the body is in rest. Okay. Now you apply some force F, and due to that the acceleration takes place in the direction of this direction. Okay. So now in for that case F net is not equal to 0 because n equals to mg, it is okay. But here another thing is introduced, that is the a force F is applied on the body, and due to that the body is moving in an acceleration in the direction of the applied force. That the direction of the force is this, and the direction of the acceleration is also same direction. Now why it is important, direction is important. Now you think in some critical way, that is the force is applied in the direction, that is the force is applied at some angle, that is the for horizontal the force is applied at an angle of theta. That is if you extend this this is the theta, if this is angle theta, then what are the forces acted over here? Here the forces acted is, if it has a mass m, then mg, same mg is acted over here, and for mg n is acted over here. And is it only n? No, it is not n, because now F has two component. One is this, if the applied force is F, this is your horizontal direction and this is theta. Now this component is called the, that is the horizontal component is called the F cos theta, and the vertical component is called the F sin theta. Why it is F cos theta? You consider one triangle, you consider one right angle triangle. This is your F, this is your theta. So if it is ABC triangle, then what is this BC? Now we know that base by hypotenuse is equal to cos theta. That means BC by hypotenuse is F is equal to cos theta. So BC is equal to F cos theta. So this is the reason that the horizontal component is F cos theta and the vertical component is F sin theta. So now this is your F cos theta and this is your F sin theta, which is acted over here. Now to redraw this structure, what are the forces now acted? So this is your acceleration. If you say this is your acceleration and this is your F cos theta, this is your applied force F, this is your mg, which is acted downward, mg, and this is acted upward, which is n plus F sin theta. Now think one thing, this is your F, this is your theta. Think one thing, if theta is equal to 0 degree, then F cos theta become what? F. That means the acceleration of the body is in this direction, is it? Now if theta is equal to 90 degree, then F cos theta become 0, but F sin theta become F, because sin 90 is equal to 1. Sin theta become F. It means that if we apply the force at an angle 90 degree, then the direction of the motion of the body is upward direction. And if we apply the force 0 degree with the horizontal, then the direction of the acceleration of the body is in this direction. That means theta, so theta is equal to 0 degree, direction is acceleration is in this direction. Here we can say that theta is equal to 90 degree, the direction of the motion is acceleration is upward direction. That means the direction is most important for acceleration of the body, and force is the cause of the acceleration. That's why force is the vector quantity. So in the next video we are going to discuss about the types of